In this video, I will be graphing one example of a piecewise function. Please watch the other video to learn what a piecewise function is or to see some more basic examples. In this piecewise function, I know that I'm going to have two parts to my graph, so it will not be one straight line. It will have two separate rays or lines going in one direction. I am going to be graphing the line y equals x plus 2 for the portion of the graph to the left of when x is 2, because it says x is less than or equal to 2. And I'm going to be graphing the line y equals negative 1/2 x plus 4 in the portion of the graph to the right of this line. Some students find it visually helpful to draw a dotted line to show that you're separating this graph, and then to see that on over here, this is the section for y equals x plus 2, and to the right is the section y equals negative 1/2 x plus 4. Regardless of whether you've learned slope-intercept form, I think that a very effective and efficient way to graph a piecewise function is to make a table of values for each section. I'll color code the pieces of my graph in order to do this. First will be the section right here. We know that this section is going to be when x is less than or equal to 2. So I'll set up my table, and I'll find the point 2 something, and then I can only pick other values where x is less than or equal to 2. So I'll do 2, 1, and 0 just to catch some mistakes. And again, we're graphing y equals x plus 2. So 2 plus 2 is 4, 1 plus 2 is 3, 0 plus 2 is 2. I'm going to graph 2, 4, 1, 3, 0, 2 to help me guide where I should be placing my line. And in this case, remember, it's not actually a line, it's a ray because it's going in one direction. That line will continue on forever to the left of the graph, in other words, where x is less than or equal to 2. To the right, I'm going to be graphing y equals negative 1/2 x plus 4. So I'll again make a table of values. Notice that this is for the domain, this is for the x values when x is greater than 2. But I want all of the values up to that. So I am going to put 2 in my table, but I'm going to remember that this is going to be an open circle because the x value 2 is not actually included in my domain here. So again, I will have points where x is greater than 2. So I could have 2, 3, 4, 5, etc. But since my coefficient of x has a denominator of 2, I'm going to choose multiples of 2, just like we did earlier in the unit when we were making a table of values. Then I'll find my y values. Negative 1/2 times 2 is negative 1, plus 4 is 3. Negative 1/2 times 4 is negative 2, plus 4 is 2. And negative 1/2 times 6 is negative 3, plus 4 is 1. So I'll graph the point 2, 3, but that will be an open circle. I'll graph the point 4, 2, and I'll graph the point 6, 1, and I will use those points to guide my line, and I will continue that pattern. I have now graphed this piecewise function. I have two pieces on my graph. I have the piece when x is less than or equal to 2, which I know is in this section of the graph, and I've graphed the line y equals x plus 2. Notice that I have a positive slope of 1, which is my coefficient of x, and it goes through the y-intercept of 2. So I can check it using all of my strategies and using slope-intercept form. Then, for the section where x is greater than 2, so that's the domain, so that is this whole section of the graph, I've graphed y equals negative 1/2 x plus 4. Notice that my slope is negative 1/2, and that if I were to continue my line, it would be going through my y-intercept of 4. Since this section of the graph does not actually continue to the y-axis, we will never end up plotting that point. This was just one quick example of graphing a piecewise function.